Okay, so once again, x squared equals negative 12y. So we will be getting the value of p by equating 4p to negative 12. So divide both sides by 4, then we can get p is equal to negative 3. So since it is x squared plus negative 12y, so our parabola opens where? Ali, right, left, up, or down?
Down, sir.
Okay, so because it is x squared, all right? So when it is x squared, the parabola opens downward. Okay. So we know that the parabola, when it is opens upward, we can have our focus as starting with 0, and the p is negative 3. Okay, so the directrix is opposite of the p. So we have directrix is equal to y equals positive 3. And our endpoints of the lattice rectum, endpoints of the lattice rectum is equal to Ramson.
Sir, negative positive 6, comma, negative 3.
Okay, so 2p and p. So you multiply that 3, so it will become positive negative 6 comma negative 3. All right, so let's graph now our given parabola. Okay, so we have 0, negative 3 is here. We have also 6 and negative 3, negative 6 and 3, and we have 6 and negative 3. And our center, our origin. So we can graph now our parabola, right? And also going there. Okay. Right. So focus is at 0, negative 3, and this one is our endpoint.
Go gigap lang.
Negative 6, negative
Okay, yun.
3.
Never mind. Ginigap lang rin pala ako. Tag ko siya twice. Tag ko siya twice.
What's that?
Yes.
I mean, once. 26 1.
And our directrix is at 3. So we have this. So y is equal to positive 3. Did you get it? So this is 5 points each. We have 1 point for the, okay, 1 point. 1 point here for the P. 1 point for the focus. 1 point for the directrix. 1 point for the endpoints, and 1 point for the graph. All right? So a total of 5 points. Okay, next, let's go to number 2. All right. So number 2, we have y squared equals 16x. So Ramsen, the parabola opens where? Yeah, tell me. Opens.
Sir, right po.
Opens to the right. The parabola opens to the right. Okay. So next, we will get 16. So 4p equals 16. So divided by 4. So P is equal to 4. So our focus is at 4, 0. Our directrix is x is equal to -4, and endpoints will be 4 plus and minus 8. So let us graph now. So we have focus is at 4, 0, 4, 0. Directrix is at -4. It's the opposite of the focus. So x is equal to -4. Our origin, and we have 4, 8. 4, 8. And 4, -8. So we will graph it. Right. Okay. So that's our parabola. Okay. So this is the lattice rectum. So hard to graph. So 1 point here, 1 point, 1 point, 1 point, and 1 point further graph. Okay? Question? Next, we have number 3. Focus at 2, 0, directrix x equals negative. So you are asked to find the equation of the parabola since you have the focus. So since you have 2, 0, so your equation will start on our y squared. So y squared is equal to 4px. So since p is 2, then we can get our equation. So 4 times 2x. So y squared is equal to 8x. So 1 point for the equation. Right? Is the equation. Next, we will get our what do you call? Endpoints. So our endpoints, plus and minus, it should be P. P is 2, plus and minus 4. Okay. So let's make it 2 points for this. Let's make two points for our, and then 1 point here. And then for the graph, it's 2 points. Okay. So it opens to the right. So we have 2, 0, 2, 4, 2, -4, and directrix is at -2. All right. So 2 points for the graphs also, for the graph. So focus is at 2, 0. We have here 2, 4, and 2, -4. And we have here as x is equal to -2. Okay? Next.
Sir,
Zero.
excuse me po. Ilang points pa yung graph?
2 points.
Okay.
So 2 points. 2 points. 2 points and 1. So a total of 5 points also. Okay, so let's go back here. 0, 4. So the parabola opens upward because the focus is at 0, 4. So therefore, we have x squared is equal to 4px. So x squared is equal to 4 times 4 times x. So x squared equals, that's y, sorry. It's supposed to be y. Y and y. This is y. And this is also y. Alright. So this is our equation. And our endpoint should be 2 times 4, so 8 plus and minus 8 and 4. So we have focus 0, 4. Then we have 8, 4, negative 8, 4. So let's move a little bit. And the directrix is at negative 4. Okay. So that's our parabola. And this is our lattice rectum. So the focus is at 0, 4. This is 8 and 4. This is negative 8 and 4. And this is our directrix. So the directrix will be at y equals -4. Okay? So again, we have 2 points for the equation, 1 point here, and 2 points for the graph. The directrix is parallel to the y-axis and passes through -2, -2. All right. So when the directrix is parallel to the y-axis, so it means to say that it is either opens to the right or opens to the left. Because the directrix can be here or can be also here. But it passes through -2, -2 here. So definitely, the parabola opens to the left, right? Because the directrix is actually parallel to the y-axis. So what is the formula for the parabola opens to the left? Nizea, where's Nizea?
Dito po.
All right, okay. So what is the formula for opens to the left? Or x squared equals what? Negative 4p.
Negative 4py po.
4py. All right. Okay, so since it is, we are sure that it opens to the left, then we need to get the value of our p. Okay, so therefore x squared we have x and this is y. So we have negative 2 squared equals negative 4p and y, which is negative 2.
Sir,
What?
the formula is positive 4py. And it's y squared po.
X. Oh, sorry. Now we have this formula that we are sure that the value is negative, right? So when it is negative, so it is y squared 4px. So therefore we have 4 equals 8p. So therefore, let us change. So we have negative 8p. So divide by 8, negative, negative. So our p is negative half. So therefore, our focus is at negative half, 0. So where is that? Negative half 0 is here. Correct? And then what about our endpoints of the lattice rectum? Ali, what are the endpoints?
Sir, I'll give the answer or the formula.
Answer.
The answer is negative 1/2
Okay.
and positive negative 1.
Eh, ba't
Okay.
siya yung nauna, bro?
Positive, negative 1. All right. So negative 1/2 and here. Okay, so this is our parabola. Make sure that it will pass through negative 2, negative 2. Right? So we have this point. No, not this one. This is the lattice rectum's endpoint. So that is negative half and plus and minus negative 1. And this is negative 1/2. So the other one is positive only. This is positive 1. And then the other one is negative 1. Okay? So let's do the pointing system. We have 1 point for this, 1 point for this, 1 point for this, and 2 points for this. Okay, so send the scores to the chat box. Who got 25?
Sir, no one checked mine po. Dahil po,
Check your own.
China was talking to me.
Check your own.
Can I see number 1 po?
Okay.
Nakajoin ko lang po
Let's
kasi.
start with number 1. Okay? Okay, so this is number 1.
Number 2 po.
Number 2.
Number 3 po. Number 4. And number 5. So number 5 po. Thank you po.
Okay. Okay, once again, parabola with vertex HK. So we have the equation y minus k squared equals 4p x minus h, where the value of the p is bigger than 0, and if it is less than 0, it is left. If p is bigger than 0, then opens to the right. Okay? So look at the focus. The formula for the focus by this time, it has h plus p and k. H plus P and K. Right? Look at the focus. And the directrix is not only about the value of the opposite of P, but it is H minus P. So they added the value of the P and H on our focus. So H plus P plus K. And then the vertex is at HK. The vertex is at HK. And then also here, when it opens to the left side, the value of the directrix is H minus P. Okay, so H plus P, H minus P. So let us try this summary of the table. So we have the summary, like now this is for the opens upward and opens downward. Okay, so we are familiar to our equation that y, now we have x squared equals 4py, right? So when it has x squared, it means that you have the parabola opens upward or downward. So look at the focus. The focus is at h and k plus p. All right, and k minus p as the directrix. The directrix of this is k minus p also. They are just the same. But the thing is, when p is bigger than 0, then it opens upward. P is less than 0, it opens downward. Now, how to get the endpoints of the lattice rectum? So these are the endpoints of the lattice rectum. Let us see the formula. So you should have this on your index card so that it's not hard for you to do, even the circles. Right, so look at the equation. The equation of when the parabola opens to the right and opens to the left, or opens upward, opens downward. Okay, so we have the focus. These are the focus, H plus P and K, but here they are reversed, H and K plus P. Okay, if P is less than 0, parabola opens to the left. If P is greater than 0, parabola opens to the right. And if the P is less than 0, parabola opens downward. And P is greater than 0, then it is parabola opens upward. Okay? So we have the equation of the lattice rectum. So the lattice rectum is xh plus p, and it is a vertical, and the length is 4p. The endpoints are this formula now. We have different endpoints. Before it was only 2p and p, right? Now we have the additional of the h and the k. So they added h and k to this. H and K. Before it was P and 2P. Same thing here. They added the H and K with the 2P and P. So the equation of the axis of symmetry is y equals K. It is K now. And then the direction is horizontal. X equals H. It's vertical. And then the directrix equation is XH minus P and vertical. Equation is yk minus p. All right, so let us try an example to apply these formulas. So remember our general math, we have this formula, right? X squared plus dx plus ey plus f, or y squared plus dx plus ey plus f. They are separated, opens to the right or left, opens, it is opens to the right or left, opens upward and downward. Okay, so let us see example 3. Ali, will you read example 3? It opens to the right, left, upward, or downwards. So let us try to discover the vertex. The vertex is at negative 2, 3. And the focus is at negative 4, 3. So remember that vertex is at HK, right? So we should determine if what would be the opening of the parabola. So since the vertex and the focus are both on the axis of symmetry, which it has the same, which is 3, right? And the y coordinates, so therefore, y is equal to 3 is the axis of symmetry, right? So this. So meaning to say that when the axis of symmetry is y, so let us try to go back to our table. When the axis of symmetry is y, is actually horizontal, right? Look, y equals a k. So the direction of the parabola is horizontal. When it is x, it is h, so it is vertical.
Sir, we can't hear
So in
you
this,
po.
what? Hello? Hello, you can hear me now? Yeah. So again, look at the direction. When the axis of symmetry is equal to y, then it is horizontal. So meaning to say that this one is horizontal. Okay? Horizontal. So it is either opens to the right or opens to the left. So by that
Sir, we
time,
can't hear you po.
why? Wait, I need to change my cord. Yeah, what about now? It's okay? Okay. Now, so we have the focus is located to the left of the vertex. So the focus is located at the left of the vertex. So meaning to say that it suggests that h is equal to negative 2 and k is equal to 3. This is the h and this is the k. All right? So now the focus now is we have negative 4 and 3. So it implies that What is the formula for the focus? So we have now the value is -4 is equal to h plus p. That is the focus. But since h is -2, we have that -2. Therefore, we can get the value of p. So we transpose the -2 to the left side. So -4 plus 2 will give you p. So p is -2. So what does this p -2 implies? So when p is less than 0, then the parabola opens to the left. Okay, so what is our equation when it is horizontal? Let's go back to the table. We have the formula h minus k squared is equal to 4px minus h. So let us rewrite the formula. We have y minus k squared equals 4p x minus h. So let us substitute the value of k, p, and h. So what is our k? It's 3. So y minus 3 squared is equal to 4 times p. What is the p? P is -2. So it will become -8 x. What's the value of your h? H is -2. So it will become +2. So that is our equation now. The equation of the parabola. Okay? So if we will graph now, if we will expand this, we can have actually expand this, it will become y squared minus 6y plus 9 is equal to -8x minus 16. So y squared is equal to or minus 6y, then plus 8x plus 9 plus 16 equals 0. So we combine like terms. So y squared minus 6y plus 8x plus 25 equals 0. This is the same thing. Or you can leave it like this. There's no problem. Okay? So now, let us graph now. But we need to identify the endpoints of the parabola. What are the formulas of our endpoints? So now they added the h and the k with the 2p. This, you remember, h plus p and k plus 2p. All right? So h plus p are the endpoints. Again, h plus p, comma, k plus and minus 2p. We just only added this. Before it was only p and plus 2p, plus and minus 2p. So we will have our endpoints that h plus p. So the h value was -2 and k is 3. H is -2 plus p, where it is -2, and k is 3 plus and minus 2 times the p, which is -2. So therefore, -2 minus 2, the endpoints are -4, and 3 plus -4 is -1. And also -4, and 3 minus -2, it will become 3 plus 4 will be 7. Okay, so these are our formulas. And our directrix formula is also here. It's xh minus p. Directrix x equals h minus p. Our h is -2 and our p is -2 also. So therefore, so x equals 0. That is our directrix. Okay, so let us now graph the parabola. Let us see how it looks like. All right. Let us insert a media for graphing. All right. So let's start first with center. Vertex negative 2, 3. Negative 2, 3. Negative 2 and 3. So that is the vertex. What about our focus? What is our focus value? Negative 4, 3. Negative 4 and 3. This is our focus. So you can see that the vertex is here. So definitely our parabola will start like this. So when the focus on the left of the vertex, then it opens to the right. When the focus is on the right of the vertex, then opens to the right. Here it opens to the left. Now let us see the endpoints. Negative 4, negative 1. Negative 4 and negative 1. At the same time, negative 4 and 7. So these are the endpoints. Negative 4 and negative 1. And negative 4 and 7. So we have our directrix is at 0. So x equals 0, it's here. This is the directrix. What else do we need? So x is equal to 0. So let us now graph our parabola. So it's over here and here. Okay, so this is our lattice rectum. Okay, so the lattice rectum formula, it has also a value where we have 4 times the p. 4 times of the p is the lattice rectum. This one, this is the length of the lattice rectum, right? Lattice rectum. How wide? So the formula for that is 4p. Then what is our p? 4 times negative 2. But since it is a length, so it is an absolute value. So the lattice rectum is 8. Because this one, look, let us count. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. This is 8. And look at the parabola. It opens to the left. It's a little bit confusing because you have to remember a lot of things. All right? But you must follow the steps. And it's a case-to-case basis also. All right? Okay, now we have letter B. On letter B, we have the value of the vertex is at 3, negative 5, and the directrix has y plus 8. Okay, 3, negative 5. Vertex is at 3, negative 5, and the directrix is at y plus 8 equals 0. Okay, what about this type of example? How can we solve when the vertex is given and the directrix is also given? Y plus 8. So meaning that y is equal to negative 8. So that is the directrix. So the directrix is opposite of the, actually for the focus, right? If you remember. So if we have that, if y equals negative 8 to the vertex 3, negative 5, so meaning to say that P is equal to negative 5 minus 8, which is equal to, or minus 8, which is equal to positive 3. So the value of your P is 3, right? So the distance of the vertex to focus P units, this means that the vertex is also 3 units away from the focus. 3 units away from the focus, right? So therefore, the coordinates of the focus should be 3 minus 5 plus P. So therefore, the focus is equal to 3, negative 5 plus 3. So F is equal to 3 and minus 2. Now, when P is bigger than 0, then what this is all about? So let us see first. So therefore, that's the coordinates of the focus, 3 and negative 2. So the equation of the parabola is the form of x minus h, x minus h squared is equal to 4p y minus k, right? So by substituting the value of the h, so h and k. So the h is 3. So x minus 3 squared is equal to 4 times the p, which is 3, and y minus k, so plus 5. So x minus 3 squared is equal to 12, y plus 5. Then we can we can expand this. It will become squaring of a binomial, x squared minus 6x plus 9 is equal to 12y plus 60. So x squared minus 6x minus 12y plus 9 minus 60. So therefore, we have x squared minus 6x minus 12y minus 51 equals 0. This is the form of the parabola. Now let us get the endpoints of the parabola. So what is the formula of the endpoints when it is opens upward? Endpoints. So again, we just reverse our formula on the previous one. So the previous one was P plus 2P, right? So we have to reverse that. It's the same thing on what we have here. So H plus 2 or H plus 2P and K plus 2P. All right? So these are the formula. All right? These are the formula for the endpoints. This. We just reverse. Before it was H, now it is H plus 2P. Okay, so H plus 2P. H plus 2P and K minus or plus P. All right. Here again, H plus 2 plus and minus 2P and K plus P. Okay. So what is our H value? Ramsen, what's the value of your H? H is 3. What about the P? P is also 3. So therefore, the K is negative 5 plus 3. So we have the value here. 3 plus 6 will be 9 and negative 2. At the same time, we have 3 minus 6 is negative 3. Negative 3 minus 2. Okay, so let us graph the parabola. We have okay, so the HK is 3, negative 5. So 3, negative 5 is over here. And our focus is at 3, negative 2. 3, negative 2. This is the focus. It's the upper part of the vertex, so that's why it opens to the opens upward. Next, we have the endpoints, 9, negative 2. So let's move over here. 9, negative 2. 9, negative 2 is here. And we have also negative 3, negative 2. Okay, so we have the directrix is opposite to that, which is 8 or negative 8. So we have it here. And what else? So that's all. And we have to connect the graphs at the points. So we have, this is our parabola. This is our vertex. So the vertex is at 3, negative 5. Right? So this is 3, negative 5. And the focus is at 3, negative 2. And the length of our lattice rectum would be 4 times the P. What's the value of our P? The P is 3. So that's why it should be 4 times the P. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Why this is only 5? It should be 3, negative 2. Again, this is, sorry, 3, negative 2. Should be 6. 3, negative 2 is over here. Right? So, until here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why the length of our lattice rectum is 12. Because 3 times 4 will give you 12. Lattice rectum. 12 units. And it is x equals negative 8. Or that's y. Because that is our it's long, right? Is it long, Ramsen? What about Ali? Did you get it? It's a little bit long. Isaiah, what's your confusion?
Sir, I got confused with the graph. Po.
Why? Once you got the focus, the vertex, it's easier for you to locate the points. But the important thing is that you should get this. You should get the focus and the vertex at the same time the directrix. I'll give you more examples so that it's easier for you to do it. Okay, now letter C. Last example we will do. The parabola passes through the point negative 1, 5 and vertex is at 1, 1. Okay, vertex is at 1, 1. Let us see. Okay, the parabola, one of the points of the parabola, it passes through here. Negative 1 and 5. And it has a vertex of 1, 1. All right. So if you have that, the vertex is at 1, 1. It's here, right? This is vertex. So either the focus is up, down, right, or left. But it passes through, one of the points is passes through negative 1, 5. So where is it? Negative 1 and 5. 1, 2, 3, 4, 5. It's here. So meaning to say that the graph is over here, right? It passes through there. So where is it? It passes through 1, and its vertex at 1 and passes to negative. So to solve for P, let us now have our equation. It is x minus h squared plus 4p, or equals 4p. And y minus k. Okay. So we have the points x and y, which is given, negative 1 and 5. So x and y. And also we have the vertex is at hk. Vertex is at 1, 1, which is h and k. So we can solve now for the value of the p. We will just replace all the values. So x is negative 1. So negative 1 minus h, which is 1 squared, is equal to 4p. We don't have the p. And y is 5. And the k is 1. K is 1 here, right? So negative 2 squared is 4 equals 4p. And then 5 minus 1 is 4. So 4 equals 16p. So divide by 16. So that's why the p is equal to 1 over 4. So as you can see that p is bigger than 0, then the parabola opens upward. So we have this here as the formula of the p. So let us substitute to our formula x minus h squared, which is 1 squared, is equal to 4 times 1 over 4 because the p is 1/4. Y minus k, the k is 1. So we have to expand this. It is x squared minus 2x plus 1 equals, we need to cancel that. It's 1 and y minus 1. So remember that's also 1. So therefore x squared minus 2x minus y plus 1 plus 1. So plus 2 equals 0. So this is the same thing there. Right? X squared minus 2x minus y plus 2. Okay, let us graph, but we need to get the, again, endpoints of the lattice rectum. Again, we just repeated, what is our formula of the lattice rectum? Ali, what are the endpoints? H plus and minus
2,
2p.
then K plus P.
P. Okay. So what is our H? H is given, which is 1. Plus and minus 2. The P is 1/4. At the same time, we have K. K is 1 plus 1/4. All right. So therefore, we have 1 plus 1/2 is 1.5, right? And 1 plus 1/4 is 1.25. And we have 1 minus, what do you call, 1/2 is 0.5. And 1 plus 1/4 is the same, 1.25. Okay? So we got this already, and then we can get our directrix at the same time. So let us insert the grid. So let us try to do graphing. So the vertex is at 1, 1. Don't we have the focus yet, right? So 1, 1. So the focus of that formula is on, the formula of the focus is at H and K plus P. H and K plus P. So focus is H and K plus P. The H is 1 and the K is 1 also. So we have plus half, 1/4. So the focus is at 1 and 1.25. That's our focus. Focus is this, 1 and 1.25. So let us try 1 and 1.25. 1 and 1.25. It's over here. And the vertex is at 1, 1. And also we have 1.5 and 1.25. 1.5 and 1.25. What's this? Oops. Again. Let's make it bigger so that we can graph it well. So 1, this is the vertex. The focus is at 1 and 1.25. Our endpoints are, what are our endpoints? 1.5, 1.25. 1.5, 1.25. 1.5, 1.5. And also here. All right, that's it. And this is the length. And also this is our directrix. Where the directrix formula has the value on the table, we have y equals k minus p. Y equals k minus p. Directrix y equals k minus p. K is 1 and p is 1/4, so it is 3/4. So therefore, the directrix is y is equal to 3/4. So this is our parabola. Now it's a little bit harder because it has h and k. All right, but anyway, that's for the parabola. We will continue on a week after to do this again. And I'm sure you will forget it because it's a little bit complicated. But anyway, just have the copy of this on your index card or on your papers, because during the exam it is open formula. So you have to get the copy of this, okay? Because you have the parabola, you have the ellipse, you have the hyperbola, a lot of like this. That's why you need to get a copy. All right. You can have a take a picture. Anyway, you have this one on your ebooks. You can grab it on your